Let's move on to the second part of lesson 11.3. We just have one example and a few demo problems. Example number 2 says find the value of each variable. We have a right triangle and you can see that we have an altitude. What we're going to do is apply the altitude geometric mean. So our altitude is h, so in our proportion we'll have h to the bottom of the first denominator and the top of the next denominator, and then we need to make our comparisons between the triangles. H is to 4. I'm sorry, 4 is to h in this smaller triangle, as 16, h is to 16 in the medium-sized triangle. Now, if you're looking for these parts to be similar, they won't be. If you don't understand why, that's because you need to reread the actual corollary. The corollary of 11.3 A, which is the altitude mean corollary, says the altitude to the hypotenuse, which is 8, of a right triangle divides the hypotenuse into two segments such that the length of the altitude is the geometric mean between the lengths of the two segments of the hypotenuse. So instead of comparing short legs and short legs, we're actually comparing the pieces of the larger triangle's hypotenuse. So 4 is one piece, so it's 4 to h, and then h to the other piece, which is 16. So if we multiply across, we have h squared equals 4 times 16, which is 64. H is the square root of 64, which is 8. Now for this example, we're going to apply the leg geometric mean. And there are actually two different ways we can do this. So we'll begin with the first one. And let's take a look at the pieces of our triangles. 4 is the short leg of the smaller triangle. 20 is the hypotenuse of our larger triangle. T is the hypotenuse of the smaller triangle, and then T is the short leg of the larger triangle. So what we have here is short leg to hypotenuse, short leg to hypotenuse. So let me say that again. 4 is the short leg to the hypotenuse of the smaller triangle, and then we're going to compare it to the short leg of the larger triangle to the hypotenuse of the larger triangle. So you should put that in your notes. And t times t is t squared equals 4 times 20, which is 80. T equals the square root of 80, which is 4 square root of 5. Now for the same corollary, we can also have 16 right here, which is the long leg to the hypotenuse of the medium triangle. And that will be compared to the long leg of the large triangle to its hypotenuse. So we have long leg to the hypotenuse of the medium triangle, long leg to the hypotenuse of the large triangle. So you have two conditions. We had in the last one, we had short leg to the hypotenuse, the two triangles that it compares. In the second condition, we have long leg to the hypotenuse. So r times r is r squared. 16 times 20 is 320. r is the square root of 320, which is 8 square root of 5. Here's an additional example, just as some review and also to help you solidify visually what you're working on. We use the right triangle PQR for exercises 3 and 4. So you can see that an altitude is dropped here, and we have now 3 different triangles. It says name each segment. So we're naming the segments of the triangles, and the first segments they're asking for are the legs of PRS. So PRS, let's take a look at this triangle, and PR right now I can see that that's a hypotenuse, so we will have a short leg, which is PS, and the long leg, which is RS. Now we want the legs of PRS. I'm sorry, that was the answer to that. Now we want the altitude to the hypotenuse of PQR. So hypotenuse of triangle PQR is PQ. We want the altitude to this hypotenuse, and that is this line right here, and that is RS. Let's find the segment of the hypotenuse adjacent to leg PR. So leg PR is right here. The segment that is adjacent would not be the altitude. The segment would be the short leg, which is PS. And the segment to the hypotenuse adjacent to leg RQ would be SQ. So it's important to know what these pieces are and understand their definitions in case you have a word problem where you have to name these. And also to be able to visualize when you have the 3 triangles. Sometimes it's hard to see that they're in the smaller triangles where the hypotenuse is, or the long leg or the short leg. Another example, additional example number 2, with the same triangles. Write triangle similarity statements for 3 pairs of similar triangles related to the larger triangle PQR. So let's start with the smaller triangle. PRS is similar to the medium triangle RQS. PR is the hypotenuse. In the medium triangle, RQ is the hypotenuse. So we should have lined up here PR and then RQ, and that is correct. And if we continue down here, our next segment, which is the long leg, is RS, and this long leg of the medium triangle is QS, and we can see that those line up, RS and QS, so that's correct. Now let's take our medium triangle and compare it to our larger triangle, and the medium triangle is RQS. We started with the hypotenuse going to the long leg, so on our larger triangle we'll go hypotenuse PQ to the long leg QR. So PQR. So RQS is similar to triangle PQR. And last, we will go with our smaller triangle to the larger triangle. So PRS is similar to PQR. So PR remembers hypotenuse, and then we did long leg, and the large triangle PQ is a hypotenuse, and the long leg is QR. So whatever system you use, I like to go small to medium, medium to large, and then I'll go small to large. So, or you can say large to small. You should have some kind of a system to make sure that you do all 3 triangles. Your homework is numbers 10, 17, 20, and 22. And if you have any questions, be sure to contact me, and then we'll be moving on to lesson 11.4.